Hello, I'm creating a video response in regards to my post on Reddit. A couple of you guys said that you wanted an explanation of promises in the event loop. So yeah, let's go ahead and get into it. I'm using this app called Run.js, and it'll help you sort of uncover what exactly is going on here. So before we get started, let me just explain the code I've got set up here. We've got a function called main, and we're returning a promise.resolve with an object here called then. And then we're calling our main function and chaining on a then, a catch, and a finally. Inside of each, I've just got two arguments to a console log, error, and info. So for log, just so that we see that there's a log here, we can see that the first argument is log, and then we get the value back, which is that then property. You'll also see that the finally is running, so we're running inside of this info. You can see info finally. And if you're wondering what this is, it's just because main returns a promise, and that's what Run.js outputs, because it outputs the values of functions. So that's not super valuable for us, but it's just an artifact of this piece of software. Anyway, let's go ahead and get into it. So the first thing I'd like to explain is a promise is a value that comes sometime in the future. That future is typically determined by your code, but if you want it to be the immediate future, you can do something like promise.resolve or promise.reject. And so in the scenario that we do promise.reject, we're falling into that error case, which is that catch block here, and we're returning that error value. And yeah, this is basically what the functionality of promises do. In order to actually get the value outside of the promise, you need to use then. If you want to get the error out of the promise, you use catch. And finally is used in the scenario where you need to do some sort of cleanup after you've gotten that value. Typically it's not used a lot. Some use cases might be maybe you need to establish a database connection, and later on you run some logic inside of the then, and then clean up the database connection in the finally block. So that could be a use case. Now, another thing is using async await. If we make this function async, you can see that we still get an error message, but interestingly enough, if I do something like this, we still get the same response. And the reason why is because async is just a keyword that basically tells JavaScript to go ahead and wrap any return or throw statement inside of a promise resolve or promise reject. It is literally that simple. It is just sugary syntax on top of JavaScript that wraps the throw or the return inside of a promise.resolve or promise.reject. So similarly, if we want to resolve a promise using async await, we can literally just return our object, and here you can see we get that log with the value then, and that's it. That's literally the difference between async await and promises. Now, there's a couple of other things that we can do here. For example, if I wanted to iterate over a bunch of different promises, we could do so. Let's go ahead and say like for let I equal 0, I well, let's first do const equals, let's do we'll create an array from a length of 10, and then in order to establish a bunch of values, we can use this callback syntax from the from method, which allows us to fill in the blanks of the array. So I'm going to say promise.resolve 1, or maybe we can say x, and x will be whatever the parameter is in here. And so now here, if I say for let I, let's not do that, let's do for const x of xs. And you can see that we're getting a promise of unknown. And so I could say await x and let's just console log this. I think this parameter is undefined, so let's do that. There we go. Yeah, so this is the value. The value is undefined, and so we use the index here inside of this method signature. And so we're getting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 because we're incrementing those indexes as this array is being built up. So now I have this thing called XS, which is an array of promises that return a number. And you can see here that X is a promise that returns a number, and we can await it inside of a loop. And that might be interesting. Another thing that we could do here is we could also return XS, and this is an array of promises, but if we do promise.all XS, now we get a log with all of those numbers, because promise.all allows you to wrap a bunch of promises into a single promise. And so the way that this works is it's promises are running in this thing called a micro queue, and the micro queue is high priority work. There's also something called a macro queue, which is a lower priority queue. It's called a Microtask and Macrotask. Sorry for the confusion there. But let's go ahead and create another function here. Let's call this async function demo, and we're going to return performance.now. And the reason why we're going to return performance.now is because it's a high resolution timestamp. And so it's going to take a snapshot of the time in a very high resolution, so we can actually see like the changes of the microtasks. So here, as we're building this up, we're going to call array from length 10, and then we'll just call demo. So here you can see that there's literally no changes to that value, but if we increase that number, you can casually see over time that this value is definitely changing. And just to make it a little bit more easy to see, we'll put it out on a table. And so over those 1,000 iterations, you can now begin to see that there is a change in that time. However, the difference is fairly small. So that's kind of interesting, right? We basically created a bunch of promises with this async function demo, and we're just returning that value. And because the function is async, it's returning a promise.resolve internally when this function gets created. And now what we can do is talk a little bit about the macro queue. So in the scenario where we want to return let's return a lazy promise. And so the way that we can do that, let's like a promise that is slower than the resolve. So we're going to create a promise, and the way that we do that is we do new promise, and in this promise signature there's two values. There's the resolve and reject functions. We're only going to be using resolve right now. So now here we're going to call set timeout, and in here we're going to resolve performance now. And so I'm not sure if it's noticeable, but we're getting significantly more timestamps here. And the reason why is because set timeout actually runs on something that's called the macro task. And so the macro task runs slower, and there's a bunch of different there's a bunch of different characteristics around this. So specifically with set timeout, you're going to be running in the macro task. And I pulled up some stuff on ChatGPT just to like help me document the APIs. So let's see here. Here we go. So a couple of things here. With macro tasks, you can create a macro task with promise, then, catch, finally. In Node.js, there's process.nextTick. There's also queue microtask, which is a newer API that exists both in Node and the browser. Mutation observer, which is something that exists in the browser. This also creates microtasks. Things that create macro tasks are things like set timeout, set interval, set immediate, and request animation frame. Typically, and this outlines it here, you can, or at least in Node.js, you're going to be creating macro tasks for I/O operations. There's also things like click events, which I believe are also things that are considered macro tasks. So like a click event, a on change event, these are all macro tasks. And the reason why they're macro tasks is because you don't want to starve the main thread. And that's actually a good thing to get into. So if you're not familiar with what a thread is, they're basically different lanes of I/O processing. So you might have a event on the main thread, and then maybe this is like a worker, and this might be like another worker in the case of a typical like JavaScript application, because JavaScript is not a multi-threaded language. You would have to schedule work out onto multiple processes, and you would do that through a worker thread. So in the scenario where you're making updates to the main thread, maybe you're in the browser, you're rendering some HTML. The reason why you want click events and any of these other JavaScript APIs to be running on a background thread is because when the user is interacting with the page, you don't want the main thread to lock. Imagine a scenario where you've got an animation running, and now as soon as the user clicks on an element, the whole page freezes. Obviously, that's not an ideal scenario. And so the reason why the macro and micro tasks exist is so that you can schedule work outside of that main thread, so that you're not constantly blocking the main task that your application is trying to fulfill. So in the browser, you're probably going to be rendering a bunch of UI. In Node.js, you're probably going to be serving a bunch of HTTP requests. And so, like, for example, one of the reasons why you would create a worker is maybe you want to do like image uploads. And if somebody sends you an image and you need to do some like resizing, you would want to do that work inside of a worker thread so that you can free up the main thread, which is going to be like your HTTP handler, to continue to serve traffic. Meanwhile, the worker thread would be resizing the image, and as soon as that was done, maybe you send some sort of WebSocket event or a server sent event and say, hey, user, your image is done processing. Go click here to see the update, right? So that's an example of why you would schedule work on a macro or micro task. But again, in that particular scenario, you'd probably create a worker, and that a worker is similar in that sense. However, it is actually fundamentally different. The idea there, though, is similar, which is you're scheduling work off of the main thread. And so typically when you're dealing with promises, if the work is not super urgent, like it doesn't need to happen immediately, you could potentially build something that allows you to schedule work, and something like set timeout, or there's another function I mentioned down here called request idle callback. And this is a browser API. So maybe, for example, you want to show notifications to a user, but those notifications aren't like super important for rendering like as soon as you get them. So you could request, or you could use request idle callback and say, hey, as soon as the server knows that we have notifications to display, let's go ahead and display 2 or 3 of them to the user when nothing else is happening on the page, right? So let's see here. What else can I explain out of this? There's also a interesting API. So with promise.all, one of the things that happens here is I could call reject here. Let's go ahead and do that, reject. And so here we are getting one of those demo values out, and one of the interesting things about promise.all is whenever the promise has failed, every promise that exists in this array is also just going to get every promise that's in the array up until the point of failure is going to stop being processed. If that's not the desired functionality that you want, you could also use something like all settled, and all settled gives you a status and a reason. So reason is the error, but in this case it's just a random timestamp because that's what we returned in the reject. And then you can check the individual status of each promise. So maybe let's do math.random, and we'll say if it's greater than or less than 0.5, we reject. Otherwise, we resolve. And so now you can see a couple of them are fulfilled and some of them are rejected. And then let's see here. So if we do promise.all, you can see we get that error, and we only get that error even if some of these values resolved. So one thing to note is when you create a promise like we're doing here, all of these promises are still running in the background, but you'll never get the value back. So with all settled, if you actually care about some of those values, you can peel those out. So yeah, hopefully this was helpful. If you guys want me to dive into any more specifics, I'm happy to share more, but I think this is good for now. Yeah, looking forward to hearing your questions and feedback. Thanks.